In this video, we are going to look at confidence intervals for a population mean, and we have done that in the past, but this time the change is that we are going to assume that we do not know the population standard deviation, whereas in the previous examples, we assumed that we did know the population standard deviation. So just as a reminder, when we did know the population standard deviation, here was our formula for a 1 minus alpha level confidence interval. But what's going to happen when we don't know sigma is we're going to have to estimate that population standard deviation with its sample standard deviation S. And this is just like we did back when we were doing hypothesis testing. Okay, so what this does, just as a reminder, is it's going to change our test statistic, and instead of a Z interval, we are now going to end up creating a T interval. And so you'll notice the only thing that's changed is that instead of using the population standard deviation sigma and having a Z test statistic here, or a Z value, now we're going to have the sample standard deviation and we're going to use a T value. Okay, so the rest of that you can read through on your own if you'd like. You have the handout there, but we're going to get into examples. So just as a reminder, what happens is we have infinitely many T distributions because as our sample size increases, our sample standard deviation becomes a better and better estimate of the true population standard deviation. What that means is that the bigger our sample size is, the closer S is to sigma, and then the closer the T distribution would be to a Z distribution. So as a reminder, we end up with infinitely many of these T distributions, and each one is defined by its degrees of freedom, which is the sample size minus 1 in this case. Okay, so the first thing we're going to do is look at an example of finding a T sub alpha over 2 value, and then we'll do a confidence interval example. So for the example here, we're told we want to find a T sub alpha over 2 value that we would use for a 95% confidence interval if our sample size was 24. So if we have a 95% interval, that means alpha is the other 5%. And so T sub alpha over 2 would be T sub 0.025 with degrees of freedom equal to n minus 1. So in our case, that's 24 minus 21, or 23. So we're going to jump over to the calculator. And we're going to use second distribution, and we're looking at inverse T. If the area to our right is 0.025, that means the area to our left is 0.975. The degrees of freedom was 23. And so we end up with a T sub alpha over 2 value of 2.069 if we round there. So T sub 0.025 with 23 degrees of freedom was 2.069. So there's just an example of how to find a T sub alpha over 2 value. And I think at this point we're ready to just jump into a confidence interval example. So this example says a study on the amount of television watched per day last year by the average person was conducted. There were 30 people included in the survey. The sample mean was 4.760 hours, and the sample standard deviation was 2.297 hours. So what I want you to notice here is that we took survey data, we have a sample mean and a sample standard deviation. That right there, the fact that it's a sample standard deviation tells us we're going to use a T interval instead of a Z interval. So if we knew the population standard deviation, we would be using a Z interval, but we don't, so we're going to use a T. We want to find and interpret a 90% confidence interval for the mean amount of TV watched per day last year. And so we're gonna need our T sub alpha over 2 value. 90% interval means that alpha is 0.1. That means we need T sub 0.05 with 29 degrees of freedom, right? We had 30 people in our survey, so N was 30. So our degrees of freedom is 30 minus 1, or 29. Let's go ahead and get the calculators out and find that. So second distribution, we're going to inverse T. If 5% of the area is to the right, that means 95% is to the left, and we said we had 29 degrees of freedom. So that T value we're gonna need is 1.70 if we round to 2 decimal places. And then we're gonna go ahead and use the formula. This formula was on the front page of the handout, but it was X bar plus or minus our T sub alpha over 2 value times S over the square root of N. So X bar, our sample mean, was 4.760 hours. Our T sub alpha over 2 value we just found was 1.70. Our sample standard deviation was 2.297. And our sample size was 30. And if you go ahead and start plugging this right-hand side into your calculator, you'll get a margin of error of 0.713, which creates an interval from 4.047 to 5.473. And so as an interpretation there, we're gonna say we are 90% confident that the mean, I'm gonna be real specific here, the population mean hours per day spent watching TV last year was between 4.047 and 5.473 hours.